Um, Hello everybody, welcome to this video which is going to be an example of non-linear programming. We'll be talking about constructing an index fund, which is a very popular kind of fund used for passive fund management. So we'll talk about that in a second. So this video is going to be about index funds, right? So index funds are a very popular type of investment vehicle in the mutual fund industry. And the idea behind it is that even though in the short term you can make money, you can beat the market, you can get a lot of returns that are much higher than what you can get from, say, just putting your money in the stock in stock indexes. In the long run, you can never beat the market. Everything averages out. You either do better as well as the market does, or maybe even worse than the market does. It's very hard to consistently beat the market. And index funds are a result of that. So index fund basically says that you have these stock indexes like, say, the NASDAQ, the NYSE, the S&P 500. You have other indices around the world like the FTSE in the London Stock Exchange, and so on. So you look at all of these different indices and you say that, well, these indices are based upon stocks, and they usually are based upon, say, the top 50 stocks on that particular index. So they are already selecting the best stocks in the market. So what if you could create a fund that sort of mimics this index? Then you can make as much money as the index does, because in the long term, indices like the S&P and the NASDAQ and the Dow Jones, they always keep going up, right, in the long term. And so what if you can match that? So that's the idea behind the index fund. So let's take this example. So there was an example in the textbook called Hawk Financial Services in chapter 5. We will extend that example and create an index fund out of it. So assume that Hawk has a substantial number of clients who own a mutual fund portfolio with the characteristic that the portfolio as a whole closely matches the S&P 500 index. What percentage of the portfolio should be invested in each mutual fund in order to closely mimic the performance of the S&P index? So if you remember correctly, there were 6 different options. So you'll notice that one of these options is missing here. I think the large cap value fund is missing here, but I think that's just so that data fits into a single slide. But what you had was you had 6 different mutual funds. Don't forget that the large cap value is here. So you have 6 different mutual funds, and these were the returns for those mutual funds for over the 5 years. So foreign stock, the foreign stock mutual fund gave you 10% return in year 1, 13.12 in year 2, 13.47, 45.52, and minus 21.93. Now, there are a couple of ways of looking at this. So you can either look at these 5 years as the last 5 years. So whenever you look at any sort of fund and you look at the data that's available for a fund, you usually have returns for the last year, you have returns for the last 5 years, and you have returns for the last 10 years. And these are the usual numbers that people look at to figure out, well, should I invest in this fund or not, right? So in this case, let's assume that these are data from the last 5 years, but it doesn't have to be data from the last 5 years. You could say that, well, this is data from 2008 when there was a stock market crash. This could be data from, say, 2013 when the stock market was going gangbusters. So you can pick years when the market was doing really well or doing really badly, and when all the funds were available, so that you can take that into account. So you can think of these 5 years as 5 scenarios that could potentially happen. And the nice thing about taking the same data for the data from the same 5 years for all of these different stocks is that if there was something going on during that time, like, say, a recession, or something really good, the real estate market was really doing really well, or maybe the oil market was doing really well, so something like that. So all of those underlying things that would have affected one of these funds would also have affected the other funds. So you can sort of say that, okay, I can ignore all those underlying variables because they affect all of these funds anyway, right? So that's one of the ideas. So by taking these numbers from those 5 years, you are sort of, you can be a little more confident about the results. Now, So what is the idea behind an index fund? The idea behind an index fund is figuring out you have all of these different mutual funds and all of these different funds. It doesn't have to be mutual funds. It could be stocks also. You have all of these different investment vehicles available to you, and you have to figure out what percentage of your total investment should go into each of these different options. So we have 6 options, like I said: foreign stock, intermediate term bond, large cap growth, large cap value, small cap growth, and small cap value. These are the 6 different investment funds that you have available. So what percentage of your total investment should go into each of these different investments, right? So that's the decision variable, and these are the decision variables here. And now the way you construct an index fund is there are a couple of steps in doing it. First step is if you look at the constraints, you'll notice that first the percentages all have to add up to 1. That is obviously going to be true. And then the other constraints are, you're saying, well, if we get returns like year 1, what are the average returns that you would have gotten based upon the investments that you made? So if I say 20%, 20%, 20%, 20, so let's say 10%, 10%, 10%, and let's say 20%, 20%, and 30%, or some numbers like that. So you have numbers that add up to 100. So if that's the case, what would the total return have been for year 1? What would the return have been for year 2? Return for year 3, return for year 4, and return for year 5. So you calculate the returns for the 5 years, and then your objective is to minimize the distance between the returns that you expect for each of these 5 scenarios and the return for S&P index. So if you look at the S&P index over the for each of these years, so for year 1, the S&P index had a return of 25. For year 2, it was 20, then 8, then 30, then minus 10. So these were the returns for the S&P index over the last, so over the 5 years that you're considering. So the objective is to minimize. So this is the variance of the return. So this is the difference between the return and the corresponding S&P index. You say, well, that's the difference, and I want to minimize the distance. So what you're basically saying is that I want my portfolio percentages to be such that I mimic what's happening in the stock market, and what is the best I can do. So here you have 5 years. You could think of taking more years. You could say 10 years, and you'll write it the same way. So you take for year 1, the return is R1. For year 1, the S&P index was at 25. The return was 25%. So the difference is R1 minus 25% whole square, R2 minus 20% whole square, and so on. So these are the returns that you get. This is the objective: minimize the distance between the returns you get and the returns for the S&P index, and that is an index fund, right? So now let's put this into Solver and solve it, so we can actually get the result. So I'm gonna open up a file. So here we have okay, so I went and I found the percentages here. So this is a text file here, so I had to type the numbers in order to spend the time on camera for that. And so these were the returns that you had. So our decision variable, so we always begin with the decision variables. So decision variables here were the the foreign stock, the intermediate bond, large cap value, large cap growth, and then large cap value, small cap growth, and small cap value. These were the investment options that you had. And of course, we also have the decision variables R1, R2, R3, R4, R5 for the returns over the 5 years. So that's what we have. Let me make this bigger. Apart from this, we also have the left hand side and the right hand side for the constraints. So let's put that down. And these here are my decision variables. Now, technically speaking, we don't really need to know what the values of R's are, but they are decision variables, so they're going to come up. So let's keep them in there. Now the objective, now this is the piece that is going to be different from the linear programming, in the sense that these are not linear, these are non-linear, so it's going to be different there. Okay, next are the constraints. Now constraints are all linear, so we're going to input the constraints the same way. Now for the first 5 constraints are the returns for year 1, the 5 years, so year 2, year 4, year 5. So these are the percentages. So I'm just going to copy the percentages over. Okay, right there. I'm going to get rid of this because we don't need that anymore. Okay, so these were the percentages. Right, so now let's look at the constraints. If you look at the constraints, the constraint says R1 equal to 10.06 times FS, blah, 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 blah. So we have the returns for the year 1, but as you know, I don't like having any decision variables on the right hand side of the constraint. I like having them all on the left hand side of the constraint. So another way of writing this is I can move the R1 to the right hand side, and it will be 0 equal to all of this minus R1, or all of this minus R1 equal to 0. So that's the other way to write the constraint. I'm going to say minus R1. These are not percentages, these are just numbers. And I don't want any decimal places right here. So this will be minus R2, minus R3, minus R4, and minus R5, and all of these have to be equal to 0. So equal to 0. Okay. There you go. Right, so the constraints are, again, all of this, which is what the first part of the percentages are, minus R1 equal to 0, because you're just moving R1 to the other side of the equation. So this side becomes, one side becomes 0, the other side has all the variables in it. So that's the way I like to do it. But other than that, you also have that the total has to add up to 100%. So all the, I have to change that again. Sorry about that. Right? They all have to add up to 100%, or have to add up to 1. Right? That's my constraint. Now the only thing, so we still have to write the sum product function. So let's write the sum product functions for the constraints. Because the constraints are all linear, we can write everything as sum product. So we'll do it the same way. Coefficients and the decision variables, which have to be absolute references. So because all constraints are linear, we can write them this way. But the objective, we cannot do that, because the objective essentially is the difference between R1 and the index fund values, right? So we know the index fund value, so let's put it down here. So the index fund returns, so that's the returns that you have. Oops, sorry about that. There. So the index fund returns are 25%, 20%, 8%, 30%, and minus 10%. Okay. So these were the returns for the S&P index, right? Our objective is the difference between R1 minus 25% squared, then R2 minus 25% squared, then R3 minus 25% squared. So we cannot just write a sum product formula. It is the sum product. It is the sum of the difference squared. So there are a couple of ways of going about it. So we can write it as a separate formula, then add these things. But let's go with the simplest option. The simplest option is just write the formula out explicitly. So I'm going to write the formula out explicitly. So we are saying R1 minus squared. So the other way of doing that, if you don't want to do this explicitly, is you can say that the difference from index squared. Now these are not constraints, by the way, so let's leave a couple of rows here. So these are not constraints. These are just saying that this is the returns that you have for the S&P index, and this is the difference from the S&P index squared. So you say this is equal to this number, the return minus, oops, the return minus the return that you get for that scenario minus the S&P index squared, right? So this is the difference between R2 and the S&P index, R3 and the S&P index, R4, R5, S&P index squared. And then the objective is just the sum of these squares, right? And that is what we have. So if you look at the, so you take R1 minus the S&P index squared. So these are the S&P index values. R2 minus S&P index, R3 minus the corresponding S&P index, R4. So for each of the years, the return is R1, but the index return was 25%. So if you take R1 minus 25%, it tells you how much off you were, how much better you were than the S&P index. The reason we are going to square it is because these numbers are negative, so we want to make them positives. So that's one way of doing it. The other way is to take absolute values, but you cannot do calculus with absolute values. Anyway, so that is the objective. That's the formula for the objective function. So with everything now, let's put this into the solver and solve it. So my objective is here, right? The objective is to minimize the distances. So that's my that's why it's minimized. The decision variables are right here. These are all my decision variables right there. And constraints, now all constraints are equal to constraints. So, and I'm going to leave it as non-linear because the objective is obviously non-linear. So I'm going to add all my constraints at once. So these all have to be equal to the corresponding right-hand side values. And all the left-hand side values have to be equal to the right-hand side values. Everything has to be non-negative and all of that. So once we are done with that, I'm going to click on solve. It's going to take a couple of seconds to solve it, but then we'll get a solution soon enough. See, there's always a problem with doing multiple steps. So I am going to write this as a single step rather than doing it as multiple steps. I'm not going to cut this out of the video because I want you to understand that sometimes with these more complex things, Excel is definitely not the right way to go. But the more complex softwares, it doesn't make sense for me to just spend a couple of weeks teaching you the more complex software because you just can use it once or twice. But Excel is something that you can use wherever you work. Right? So you take each of the differences. Now, if you're not comfortable with this, you can put a parenthesis around the whole thing. But the order of operations will make sure that the you don't really need these parentheses, right? Let's try this again. It's also likely again that the solver is not going to give us an answer. That's fine. That happens. I will post the solutions up on Canvas. And this is one of the issues with nonlinear programming, that sometimes you just don't find a, see, solver could not find a feasible solution. Let me open this up. I'm gonna try something else. Okay, that's okay. One last try. Okay. Now you'll notice that this is the setup for the problem, right? And I don't need this either. Now I'd already solved this problem before. Let me open it up. There you go. And that's the solution. So this will happen sometimes. So there's nothing you can do about it. If it happens, you just tell me that it happened, and as long as the setup for the Excel file is correct, I'll give you full credit for it. But it's the exact same formulation, as you can see. There is absolutely no difference between this formulation and the formulation that you have. But here we're not getting any answers. And that's telling you, for the larger problems, Excel really is not the best way to go. But that's what we have, and that's what we're going to use. Anyway, so this is the final solution. So according to this final solution, 6.3%, let's reduce by 1 decimal place, right? 6.3% in foreign stocks, 5.6% in international bonds, 17.7% in large cap growth, nothing in large cap value, 27% in small cap growth, and 43.4% in small cap value. That will give us the best difference. So you'll notice that most of these values are such that the return that you end up getting, the difference in returns, is 1.14%, which is pretty good. So in the first year, you got a return of 27%, which is pretty close to the 25% that you have in the return that you have. So if you look at the return values, the index return values, let me get the right one again. Right. So we get a return of 27 with S&P is 25%. We get a return of 19% in the second year. S&P is 20%, 5.28, 8%, 28.33, 30%, 0% in the fifth year, and minus 10% in year 5 for stock market. So we're very close to the stock market index. So That's basically what we have. Right? So this is the idea of an index fund. So you create a fund which sort of mimics what's going on in the stock market. That way, because the stock market in the long term is going to go up, you expect that the portfolio that you have will also go up at a similar rate. Right? Okay, I'll post the video up and the Excel file up also on Canvas. All right, take it.